Good day, everyone. I am Master Ryan. Merivit Education Center would like to present to you Mathematics for Active Learning for P.6. We will learn about highest common factor or HCF. Let's get started with our lesson. In this lesson, you will be able to find the highest common factor, HCF, using different methods, namely listing method, prime factorization, and repeated short division. A piece of paper measured 36 centimeters by 48 centimeters. Pajari wants to cut the paper into equal-sized squares to fold into paper cranes without having any remaining paper. What is the greatest number of paper cranes Pajari can fold? To answer this question, we will learn about highest common factors or HCF. Before we proceed, let's have a review about common factors. What are the factors of 15 and 45? It's 1 times 15 and 3 times 5. Are there any more factors of 15 aside from the factors that we have mentioned earlier? You're right. There are no more factors of 15. Now, let's find the factors of 45. What are the factors of 45? It's 1 times 45, 3 times 15, 5 times 9. Are there any more factors of 45 aside from the factors that we have mentioned earlier? That's right. There are no more factors of 45. Next, we will encircle the common factors from 15 and 45. Let's start. Is 1 a common factor? Yes, 1 is a common factor. So we will encircle 1. How about 3? Is it a common factor? Yes, 3 is a common factor. So we will encircle 3. How about 5? Is it a common factor? Yes, 5 is a common factor. So we will encircle 5. How about 9? Is it a common factor? No, 9 is not a factor of 15. So we will not encircle 9. Is 15 a common factor? Yes, 15 is a common factor. So we will encircle 15. Will we encircle 45? No, we will not encircle 45 since it is not a common factor of 15 and 45. So the common factors of 15 and 45 are 1, 3, 5, and 15. We are going to find the common factors and the highest common factor of 18 and 24 using listing method. First, we will find the common factors of 18 and 24. Let's list the factors of 18. You're fast! The factors of 18 are 1, 2, 3, 6, 9, and 18. Next, let's list the factors of 24. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. Let's proceed with identifying the common factors of 18 and 24. What factors are common in 18 and 24? What factors are not common? Yes, 1, 2, 3, and 6 are common factors of 18 and 24, while 4, 8, 9, 12, 18, and 24 are not common factors of 18 and 24. Now, we will find the highest common factor of 18 and 24. Among the common factors, 1, 2, 3, and 6, which is the largest number? Yes, 6 is the largest number among 1, 2, 3, and 6. So, 6 is the highest common factor. Let's use another method of finding the highest common factor, or HCF. We are going to find the highest common factor of 18 and 24 using prime factorization. First, we will write the prime factors of 18. What are the prime factors of 18? You're right. The prime factors of 18 are 2 times 3 times 3. Then, what are the prime factors of 24? Good! The prime factors of 24 are 2 times 2 times 2 times 3. After writing all the prime factors of 18 and 24, we will encircle the common factors. So, what are the common factors? Yes, 2 is a common factor. So we will encircle together factor 2 in 18 and factor 2 in 24. Are there any more common factors? Yes, 3 is a common factor. So we will encircle together factor 3 in 18 and factor 3 in 24. Are there any more common factors? There are no more common factors, so we will multiply the common factors that we have encircled earlier. Please note that the total value of factor 2 in 18 and factor 2 in 24 are encircled together is 2, as well as the total value of factor 3 in 18 and factor 3 in 24 that is encircled together is 3. Then, multiply the common factors. 2 times 3 is equal to 6. So the highest common factor of 18 and 24 is 6. Let's move on to another method of finding HCF. We are going to find the HCF of 18 and 24 using repeated short division. First, we will find a prime factor that can divide both 18 and 24. What prime number can we divide both 18 and 24? Yes, 2 is a prime factor of 18 and 24. So, let's start dividing 18 and 24 by 2. 18 divided by 2 is 9. 24 divided by 2 is 12. 9 and 12 can still be factored out, so we will continue dividing. What prime number can divide both 9 and 12? Yes, 3 can divide 9 and 12. 9 divided by 3 is 3. 12 divided by 3 is 4. Is there a prime number that can divide both 3 and 4? No, there isn't. So, we will multiply 2 and 3 to get the highest common factor. The highest common factor of 2 times 3 is equal to 6. Among 3 methods of finding HCF, which method is easiest for you? Let's have another example of finding HCF. We will find the HCF of 105 and 165 using prime factorization. Let's list the prime factors of 105 and 165. The prime factors of 105 are 3 times 5 times 7. while the prime factors of 165 are 3 times 5 times 11. What should we do next? You're smart! We will encircle together the common factors. 3 is a common factor. 5 is a common factor, so we will encircle them. Are 7 and 11 common factors? No, 7 and 11 are not common factors. What's the next step? You've got a sharp memory. Yes, we will multiply the common factors grouped together. So, 3 times 5 equals 15. So, the highest common factor is 15. Let's continue with another example. We will find the HCF of 24, 32, and 56 using repeated division. So, think of a prime number that can divide 24, 32, and 56. Did you say 2? Let's start dividing 24, 32, and 56 by 2. 24 divided by 2 is 12. 32 divided by 2 is 16. 56 divided by 2 is 28. Let's continue dividing 12, 16, and 28. What prime number can you divide by 12, 16, and 28? Yes, you're right. 12 divided by 2 is 6. 16 divided by 2 is 8. 28 divided by 2 is 14. What prime number can you divide 6, 8, and 14? Yes, 6 divided by 2 is 3. 8 divided by 2 is 4. 14 divided by 2 is 7. Now, is there a prime number that can divide 3, 4, and 7? You're smart! There is no prime number that can divide 3, 4, and 7. What should we do next? Brilliant! We are going to multiply the common factors. So, 2 times 2 times 2 is equal to 8. The highest common factor is 8. Are you up for a little challenge? Let's answer this together. Division. Let's discuss our answers. 126, 168, and 210 can be divided by 2. So, 126 divided by 2 equals 63. 168 divided by 2 equals 84. 210 divided by 2 equals 105. Now, what prime number can divide 63, 84, and 105? You're correct! 3 can divide 63, 84, and 105. 63 divided by 3 equals 21. 84 divided by 3 equals 28. 105 divided by 3 equals 35. What prime number can divide 21, 28, and 35? You're fast! 21, 28, and 35 can be divided by 7. So, 21 divided by 7 equals 3. 28 divided by 7 equals 4. 35 divided by 7 equals 5. Then, we will multiply the common factors to get the highest common factor. 2 times 3 times 7 equals 42. So the highest common factor is 42. Next, let's answer exercise number 8 on page 52. Find the highest common factor of 360 and 540 using prime factorization method. The answers to these numbers are written in index notation. Let's discuss our answers. The prime factors of 360 is written in index notation 2 to the power of 3 times 3 to the power of 2 times 5. While the prime factors of 540 is 2 to the power of 3 times 3 to the power of 3 times 5. First, let's write the factors in the usual way so we can group together the common factors. 360 can be written as 2 times 2 times 2 times 3 times 3 times 5, while 540 can be written as 2 times 2 times 3 times 3 times 3 times 5. Now, what's the next step? Clever! We will group together the common factors. So, factor of 2 in 360 and factor of 2 in 540 will be grouped together. Another factor of 2 in 360 and another factor of 2 in 540 will also be grouped together. Factor 3 in 360 and factor 3 in 540 will be grouped together. Another factor 3 in 360 and another 3 in 540 will also be grouped together. Lastly, factor 5 in 360 and factor 5 in 540 will be grouped together. Then, we will multiply the common factors that are grouped together to find the highest common factor. So, 2 times 2 times 3 times 3 times 5 equals 180. The highest common factor is 180. Did you get the correct answer?
Amazing!
Now that we have already learned how to find HCF using different methods, we will answer the question about paper cranes that we had earlier. A piece of paper measured 36 centimeters by 48 centimeters. Pajari wants to cut the paper into equal-sized squares to fold into paper cranes without having any remaining paper. What is the greatest number of paper cranes Pajari can fold? What do you think is the keyword in the problem? You're smart! Yes, the keyword is greatest. This means that we are going to use HCF to find the greatest number of paper cranes that can be folded. So, let's find the HCF of 36 and 48. 2 is the prime factor of 36 and 48. 36 divided by 2 is equal to 18. 48 divided by 2 is equal to 24. We have to continue factoring out 18 and 24. 2 is the prime factor of 18 and 24. 18 divided by 2 is equal to 9. 24 divided by 2 is equal to 12. Can we still factor out 9 and 12? We can still factor out 9 and 12 and their prime factor is 3. 9 divided by 3 is equal to 3. 12 divided by 3 is equal to 4. Is there a prime factor for 3 and 4? You're right! There is no prime factor for 3 and 4. So, the HCF is 2,
times 2 times 3 equals 12. The greatest number of paper cranes that Pajari can fold is 12. Please take note that the highest common factor, HCF, is the largest factor among all common factors of 2 or more numbers. Prime factorization, repeated short division, and listing method are the methods to use in finding the highest common factor, HCF, of 2 or more numbers.
Hope you have fun learning today. See you in the next episodes.